Very good morning. Good morning to everyone.
Good morning, Mr. Good
morning. Okay. Before we start, I think we'll share the screen for the attendance for our students to scan the attendance. So for UNIMAS students, please scan this attendance.
Không ạ.
Good morning. It's Dr. August is here. Dr. August.
Good morning, Dr. Jerome.
Morning, Dr. August. Dr. August, can we start now?
Okay, please.
Okay. Great. Very good morning to everyone. And so this is the public lectures from between the two universities, between the Universitas Muhammadiyah Yogyakarta and also UNIMAS here. So this public lectures will be on the econometric. So we have three speakers here. So first will be for myself. Okay? So I'll be discussing or sharing about the basic concept of this econometric. And also later on, we have Associate Professor Dr. Evan Lau. So we share about the applications of this econometrics. And also with Dr. August from UNY, who will be sharing with us about the modeling is in the dynamic perspective. Okay. So we start with the basic, and then we later on we go through the applications, and also from the basic application of the econometric, and then later on from the dynamic perspective. Okay. So I think without further ado, so I will begin with sharing.
Okay.
So
Econometric. Econometric.
so I will start with the sessions for more on the basic approach concept about this econometric. Okay? So it'll be good sharing stations between the both universities students who are taking this econometric course. Okay? So we have different sharing stations from different point of views with regards on this the econometric for the students who are taking this course this semester. Okay? So that is the purpose of these public lectures for this morning. So I will start in terms of the presentations outline. First, we talk about a bit on this the econometric, and then some of the important concepts and the diagnostic test. And later on, we'll be very brief on this time series analysis and on the panel data analysis. So when you're talking about this, the econometrics, we can see that it's applications of the statistical and mathematical methods. Eh? So what is important here is we try to apply these two concepts in analyzing the economic data. Okay, so with the purpose of giving this empirical content to economic theories and also verifying them or even refuting them. Right? With the application of the statistical, mathematical, and economic theory hypothesis to the analysis of the economic situations. So we can see that even we can relate to the current situation. If you look at the COVID-19 pandemic since 2020, so a lot of these policy makers come up with these certain strategies like the stimulus package. But before they reach into that decisions, normally they need to have some analysis. Okay? And then this is where the econometrics knowledge and skills plays a very important role here, because from this econometric approach, then we'll be able to estimate and even to forecast the futures, okay? Maybe the cover or next couple of years. And then from there, we can come up with the policy and recommendations for the implementation. Okay? So that is where these econometrics skills and knowledge is very crucial. So in terms of the modeling part, okay, so we know that here is the very general equations in terms of the model specifications. So basically, we have three main types here. For example, like in looking at the time series, means that the variations will come from the period, okay, the time perspective could be from the different years, could be in terms of monthly or quarterly. You know. And then the second one is from the cross-sectional analysis, means that is from the observations perspective. Eh? It can be through the firm's perspective, the country's perspective, or even the individual's perspective. So when we stack these time series and cross-sectionals together, then we will have the panel data analysis where the variations will come from time perspective and also the cross-sectional perspective. So you can see here the subscript notation here will be INT, means that the combinations of the two dimensions from the perspective of the times and also from the cross-sectional analysis. And this is some of the basic concepts that I would like to share or to highlight, revisions to all the students here. Okay? So in terms of the interpretations, it's very important that most of the time we are more concerned about the estimators of the parameters, especially on the, for example, like this, the beta head. So this is the formula that you come across. Okay? And then basically you can see that it is based on the covariance between the x and y, and you divide by the variance of x. So that will provide us with the estimators of this beta head. And the other one is this alpha. So in terms of the estimating this alpha head, so this is the formula, is the y bar minus the multiplications between the predicted beta with the x bar here. All right. So this is very common, the formula that we have come through. And I believe that during the lecture class, I think the lecturers also go through in the deriving, how to derive these formulas. Okay. But what is important here is in terms of the interpretations wise. Okay? So normally what we're more concerned is how are we going to interpret those estimators, the beta head and the alpha head in this case. Okay. So there are three A's that normally we need to type on. For example, like the first one is in terms of the significance of the estimators. The second one is the sign, and third one is the size. So this is a very general thing that when we learn the econometric, we all the students need to know about this. Okay? And even from the researchers, we also based on those guidelines to help us to decide whether we reject or not reject the null hypothesis. Okay? So in terms of this significance, normally have this components here we need to look into. It's either from the confidence levels or could be from the significance levels. Okay? So here we have 90% or 95% or 99% confidence level. And then in terms of the margin errors that we allow is could be that is not at the significant level, could be in terms of 10%, 5%, or even 1%. Okay? But most of the time when we use it this the average, right? I mean in the middle one is about 95% confidence level, or in terms of significance level is 5% significant levels. Okay. But this critical value is I put it here is just in general, okay? Because normally time series or analysis we need to have more observations. The more the better. Okay. So in general, if you have a large sample size, so this is the critical value, general critical values that we may obtain in terms of 90% confidence level. So the critical values will be about 1.65. 95% confidence level, then the critical value will be about 1.96 and 2.58 for confidence level 99%. Okay? So those are very general guidelines that normally we refer to. Okay? And in terms of to determine the decision rules, so normally will be based on either the probability approach or the statistical approach. Okay? So this is normally the guideline that we can refer to. So in terms of the probability approach, then we will need to look at in terms of the probability value, whether is it greater or less than the significant levels that we need to select just now. So when the probability value is greater than significant levels, so it means that we do not reject the null hypothesis. So as a conclusion that we can make is that the estimators is insignificant. Okay? So on the other hand, when the probability is less than the significant levels, then we have enough evidence to reject the null hypothesis. Then we can state that or conclude that this variable is significant, statistically significant. So that will be from this probability approach. And this is just a very simple examples that I would like to share here. And this is just the general models specifications. And what we are doing here is in terms of the individual testing. So we need to test those estimators, the coefficients here. Are they statistically significant? Okay? So it can be based on this, the probability approach. So, and then we need to know what is the null hypothesis that we are testing. So in this case, normally how do we test is we test all the betas here. Now hypothesis will be in terms of either the beta is equal to 0, or in terms of the alternative is the beta is not equal to 0. So we are testing individual estimators here. Okay. So, and then you have this is the output from this e-views. So we need to base on the guideline that I shared with you just now to help us to decide whether do we reject or do not reject the null hypothesis. So those are the very common things that we have go through, and then we need to base on the guideline to help us to decide to determine individually estimators whether are they statistically significant or not. And the other approach is in terms of the statistical approach. So basically, we need can refer to these the statistical values in terms of either is it greater than the critical value, then we can reject the null hypothesis, or if the statistical value is less than the critical values, then we do not reject the null hypothesis. So as a conclusion, means that it is not significant. So this is in terms of the statistical approach. Okay? So the way the setup of the hypothesis will be still remain the same. It does the matter of the approach that we are using here. Okay? So if the sample size is smaller, then you need to find for the t-tables the exact critical values that we need to identify from here. Okay? But what I'm trying to say here is in terms of the interpretation wise, normally we need to refer to this guideline. Okay? So basically, in terms of the interpretations of the significance level, we have two approaches. One is the probability approach, and the other one is the statistical approach. That will be for the first S. For the second S is and the third is in terms of the sign and the size. So the sign is very important because it's either positive or negative sign. When talking about the positive sign, it means that we are looking at the variables are moving in the same direction. And talking about the negative sign, it means that the variables are moving in the opposite direction. So what does it mean here is, for example, we look at this same as example just now. So the dependent variable is ln ln ns here, and then the independent variable is ln CPI and also ln RGDP. So in terms of this interpretation wise, normally we will look at the sign. Okay? Is it positive or negative? So it means that we're looking at the marginal impact. If the independent variables, for this case is LNCPI, will increase by 1%, then the dependent variable will also increase by 0.378%, holding others constant. So these are the standard, ways how we interpret the results from the output here. So whenever we have this positive sign, it indicates that the two variables will be moving in the same direction. The increase, independent variable increase, then the dependent variable will also increase accordingly. So if it decrease, it will also decrease. So normally you can put it in the one statement altogether here. And if you look at the coefficient for this one, the LNRGDP is a negative sign. So it indicates that it's a opposite directions movement. So for example, if the independent variable increase, then the dependent variable will decrease. So you will always be in the opposite direction. So that is where the sign is very important. And the size is the magnitude of the changes on the dependent variables stated here. So in general, normally the 3S is very important as a guideline for us to look into in terms of is it either statistically significant, and then the sign is to show the movement of the two variables. Are they moving the same directions or are they moving in the opposite directions? And then also the size is the magnitude of the change. The independent variable change by 1 unit or 1%. So what is the impact, the magnitude change on the dependent variables? So those are the important things that when it comes to the interpretation wise. Okay. So here it does also very brief on this the classical assumption. I believe all you our students already go through about this the classical assumptions. So basically, this is very important for us to know, because most of the time we are trying to draw the inferences about the true beta or how close our estimated beta to the true beta, because we are using the sample to infer the whole population. So therefore, there are some classical assumptions that we need to go through here. And for example, like the first one we're talking about the linear in parameters means that the parameters will be in the linear form, right? It's not in the non-linear form. Okay? And then the second assumption is the explanatory variables are non-stochastic. So that is also one of also very important things that we need to assume, okay? Assumptions. And the third assumption is more interesting because we are looking at the error terms, okay? Behaviors of the error terms. So normally we'll assume that it is a zero mean of the error terms or the disturbance. Okay? So the expectation of the error term conditional upon the xi should be equal to 0 by assumption. Okay? And then for the assumption of 4, also related to the error terms here, is we assume that it's the equivariance of the error terms. So what does it mean? It means that we're talking about the homoscedasticity case, where it means that the variances of all the observations will behave the same way. So you can see that the distribution pattern, they are the same. So this will be known as the homoscedastic. And if this assumption does not hold, it means that each observations will carry different variances. Then it means that we are experiencing this heteroscedasticity case. So what does it mean? It means that the distribution pattern is different based on each observation, as stated by this diagram here. And then the fifth assumption is also related to the error term. So in talking about the autocorrelation between the two error terms here. So it means that there are two different error terms if they are supposed to be not correlated. So if they are correlated, means that there's violations of these assumptions, then they will be experiencing this zero correlation problem. And then the sixth assumption number 6, also about this the error terms, is where you have these correlations between the explanatory variables, the independent variables with the error term. So the assumption should be equal to 0. But if this does not hold, then you will having this endogeneity problem. And then assumption number 7, as usual, the number of observations must be greater than the number of the parameters to be estimated, where the n must be greater than the k. Okay. And then assumption number 8 is about the x value. It has to be variability. It cannot be just a constant one value for all the observations because of this part. If this is constant, then we cannot calculate the estimators here. So it has to be a variability in the x value. Then assumption number 9, correct, must be correctly specified. And assumption number 10 also very interesting because this is the assumption we assume that there's no correlations between the explanatory variables here. For example, like x2i and x3i, it shouldn't be correlated. Okay? So if we have correlation between the independent variables, then we will having this multi-collinearity problem. So those are the 10 classical assumptions that we have gone through, and it's very important for us to check later on to see whether it holds or not. Right? And then I believe all of us also go through this about the properties of the OLS estimators, so which is normally known as the blue here, in terms of the linearity. And the second one is in terms of the unbiasedness. So this means that your expectations of the predicted data is supposed to be close to the true data. And so that we can claim that it is not biased. Okay? So this is in terms of graphical presentation to be something like this. Sometimes it could be overestimated or sometimes it could be underestimated, but we're trying to assume that these properties must hold to ensure that there's no unbiasedness problems with regards to the estimators that we estimate just now. And the third one is in terms of the efficiency. This means that we're referring to the minimum values of the variance. So the estimators carry the minimum variance. This means that this estimators is very efficient. And in terms of the consistency, that means that we're referring to the sample size. The larger the sample size, then the expectations of this beta head will be converging closer to the true beta. So this is represented by this equation. So n can converge to infinity, means that the larger sample size better, that where the estimators could be closer to the true beta. Okay. So those are the blues properties in terms of the linearity, unbiasedness, efficiency, as well as the consistency. And the other one is in terms of the coefficient of determination, the R squared. So this is also an important indicator for us to refer to see how the variations in the independent variables can explain the variation in the dependent variables. So because we can see here, basically the R squared is looking at the errors, the explanation variations come from the regressions here. So how can the models that we come out can explain the variations in the Y here. So if you look at this Valentine view, it can be reflect on this the R squared or the coefficient of determination. So where's the integrations that we have? So the greater the gray area here means that the X can explain the Y. So this is something that as the guideline that normally can refers to. Right? So I believe that this is a formula that we have looked through before, where the range for the R square is normally between 0 to 1. So the next one is talking about a very brief on this the time series analysis. So basically, it depends on the stationarity levels that we have in terms of our time series data that in our hand. So most of the time will be between these two sides here. Could be stationary at the mixed level, sometimes can be stationary at the level, sometimes can be stationary at the first difference. So we have mixtures of the integrations orders, then we normally can apply the LDL method to use. But if all the variables are stationary after the first difference, then normally we'll proceed with this integration test. So this part will be on the unit testing or stationarity testing, and then this one will be on the co-integration testing. So both two are more on the testing. So if it is co-integrated, then normally you proceed with the ECM or the VCM. If not co-integrated, then normally we proceed with unrestricted bar here. Right? So most of the time we will be more on either this one or this one. Right? So it depends on the prior circumstances that we have with regards to the stationarity of the time series variables that we have in hand. So this is quite common standard procedures that normally we need to perform in terms of the stationarity testing, normal equilibrium testing, and then before we can estimate the impact, right? And then in terms of this unit testing, there are different types. You have the conventional, and then you have the one is you also can capture the structural break here. So conventional one like the augmented decoupler, the Philip parallel. So a lot from here that we can choose, and then we can select to perform those stationarity testing, right? And then you want to incorporate the structural break. So there are different types of the structural break method that we can apply in terms of this unit testing. And this is the general co-integration test that we can perform in Johnson and Dusseldorf. So we have the trace and the eigenvalues that we can refer to. And this is the one that we're talking about the VCN. So after testing the stationarity and after testing the co-integration, then normally we need to estimate. So what is the impact of the independent variables towards the dependent variables? We can use these normalized equations to understand the behaviors of these independent variables, how it will affect the dependent variables. And here we also can include these the ECT, the error correction term, the speed of adjustment. If there's a short run deviation, so how long will it take to converge to the long run equilibrium that can be captured under this error correction term here. And in terms of the gradient causality based on the VCM, so normally you also can estimate on that. Then normally you can provide in terms of the diagram to show the causality. It can be bidirectional causality or could be a unidirectional causality or even no causality at all. Okay? So those are quite standard procedures that normally we will perform when we do the time series analysis. So regards to the estimations, the other part is in terms of the diagnostic testing. So we need to ensure that the result that we have can pass through those diagnostic tests. Okay? So as usual, based on the classical assumptions, so we need to apply some of the testing. For example, like the first one is got free serial correlation test to test on these serial correlations. So first, based on the classical one of the classical assumptions, the RAM series state is to test on the any misspecifications of the model. So the Jack Barra is to test on the normality test, whether there's any outliers or not. They have this heteroscedasticity test to test on the behaviors or the variance of the observation. Are they stay the same or they carry different variances? So there is quite a standard diagnostic testing that we need to perform. Okay? And in terms of the stability of the model, then normally we can perform this custom and custom square test, where you can provide here in terms of the diagram graphical presentation. As long as the blue line is within the red dotted line, that is considered as a stable models. So those are among the standard diagnostic tests that normally, as the researchers, we will implement, we will adopt those testing to ensure that the results can be used for the policy recommendation later on. So this is just another example from the papers in ARDL. So what I'm trying to say here is when you apply to the estimations output, normally this is what we need to know. Okay? The coefficients, we find, then we put the asterisk is to show the indication either significant at what percentage here. And then you also can capture the short run, the ECT, and normally we will present also the diagnostic testing as well. Okay? It's quite standard diagnostic testing that normally we will perform in the time series analysis. This is the custom test in terms of the stability test. So the last part that I would like to share a bit is on this the panel data approach. So we'll be very briefly on these the theoretical basic part of it. Okay? So we have these the short panels or not the micro panels is where the N is the, for example, like the country is more than the year, N greater than the T. And then the macro or the long panel is normally for the N is less than the T. So for this micro panel, we have the static, in terms of the pool RS. And the static models is the fixed effect models and also this random effect models. And then we have the dynamic models. We can use this here and to choose it. Okay? And in terms of this macro panel, it's just like the time series. Okay? So now just put it in terms of the structures of the panel. Okay? So now we have this panel integral test. We have the panel configuration. And then when it comes to estimations, we can apply the fully modified OLS or dynamic OLS or even the pool mean group estimator. Okay? So those are quite standard procedures that we can use in terms of the panel data. So here just briefly share with you a bit how do we distinguish between these two fixed and the random effect here. So it doesn't matter of how we treat this unobserved heterogeneity here, the UI and the lambda t can be changes in terms of the different observations or could be changes in terms of the different time. But you can see that this is the panel structures in IET, but this unobserved heterogeneity here is only carry one perspective on either I or either the T. So it doesn't matter of how we treat this one. So if we run the panel data analysis, this is not in the pool RS where we assume that the UI and the lambda t is equal to 0. Okay? But in reality, this may not be the case. So therefore, they come up with this the fixed effect models and also the random effect models where basically they will treat this UI or the lambda t is not equal to 0. So it means that there's some effect here, but it cannot be captured under this pool RS. So that's therefore they introduce these the fixed effect models where you have these two components here, either based on the least squared dummy variables or can be based on the within estimators transformation. Okay? So now it doesn't matter of how we treat this unobserved heterogeneity here. So if we lump this together into this intercept here, then it will be under these fixed effect models. And if we treat this unobserved heterogeneity here together with the error terms, then we come the composite error terms that will be under this random effect model. So this is basically a very general perspective how we can differentiate the fixed effect models and the random effect models from this perspective in terms of how they treat this unobserved heterogeneity elements here. And of course, if you have different models, then normally we need to select which models to use. For example, you have the pool RS and the random effect models, then normally you can use this DPLN test to determine which model is appropriate for us to proceed with the estimation. And then if you want to choose between the fixed effect models and the random effect models, then we will use this Hausman test to decide which model is appropriate for us to proceed with the next stage in terms of the estimation. So that is for these are the micro panels. Okay? So the other part is macro panels or the long panels. It's just like the normal way that we do the time series. So we have this the panel unit testing. So there are first generation, second generation. So we can choose and apply those panel unit testing here. And then as usual, after you test the stationarity, then you can proceed with this reconciliation. So basically you have this Carl, Larson, and Pedroni, but most of the time we'll be using this Pedroni because they consist of 7 statistical approaches. One is within the dimensions, and then the other 3 is between the dimensions. So they have 7 statistical values that we can refer to in order to decide whether there's existence of the long run equilibrium or not. And then next is in terms of the estimation. Normally we can use these the mean group estimators will be just like the ALDL concept as well. Okay. So this is just examples in terms of the output where in between these the mean group and also the pool mean group together. So we also use this Hausman test to decide which model is appropriate for us to interpret the results. Right. So here just very briefly to go to share with all of you with regards to the basic concept of this econometric, and then also we to share with you about the perspective of the time series analysis, and also now is the panel data analysis. Okay. So I think the next 2 speakers will be sharing more on the application of this econometric concept. And then my associate Professor Dr. Evan Lau, so he is also very prominent researcher in our faculty. So he has a lot of researchers. Then later on, he will share some of the very interesting applications of this econometric concept. And so Dr. August later on will also talk about the dynamic approach. Okay? So it'll be more on the applications of the econometric concept here. Okay, so I think that will be all from my side. So thank you for your listening. So maybe can I proceed to invite Professor Dr. Evan Lau to share his presentation with all of us. Dr. Evan Lau, the floor is yours.
All right. Very good morning to everyone. I will share my slide first. Let me go ahead and that's my slide first. Just for a while. All right. Yeah, it's supposed to be here. Okay. Yes. Bear with me for a while. Okay. I'm very honored to be here this morning to have some friends from Indonesia, and certainly also our own students here in UNIMAS, and also the Universitas Muhammadiyah in Jogja, a place that I miss in Jogja also. Let me get to these slides. Right. So based on what Dr. Jerome has just mentioned just now, he provides some very good insights actually especially on what econometrics is all about from the perspective of the from perspective of analysis, and what econometrics can be used as a policy making for the country, for a firm, for even individual to know actually about not just economics relationship, but as long we have the types of data that is suitable, then the kinds of methodology that is also suitable to estimate the relationship. So that's a very good brief and very informative introduction from that perspective. From if you have cross-sectional data, what sort of methodology that is suitable? If you have time series, what sort of methodology that is suitable? And if you have panel types of data, what sort of things that you can get involved? So we're very thankful for him, and this paper that I'm going to present, actually, or this research that I'm going to present, a very short one, is actually a research that done by me and some of the co-authors that you've seen all the names there, not just myself. So it's like a group work, but then again we send this for publication, and then we managed to get a place in the publication. I'll tell you later in a while. And this has been authored by 5 here from a collection of work from UPM, and then myself in UNIMAS, and then we have UUM, University Utara Malaysia, and also from PEKESO under the Center of Future Labor Market Studies, right? So those of you who are interested, and this application are mostly towards time series. So we're doing time series analysis, as what been mentioned by Dr. Jerome just now, from testing unit root up to VAR or the VECM or the causality direction in that particular sense. So the title here has been mentioned. As I'm going to do this is about testing the farmer's stock market unemployment hypothesis. Means that we are trying to test the relationship between stock market and unemployment, especially during the COVID-19 pandemic in Malaysia, which is what although we are going into endemic and the countries in the world are going to endemic, but the impact or the hypothesis or such an impact are still there. So this is what my part introduction. Right, this is to showcase to our friends in Indonesia. This is actually our main door to coming into the university. So hopefully everyone that listen to this particular lecture this particular morning, and including Dr. Agus, Dr. Dimas, and the rest of the team from Universitas Muhammadiyah Jogja would visit our university very soon to Faculty of Economics and Business in University Malaysia Sarawak. So we hope the students, also the postgraduate student, the S1, S2, S3, perhaps you can visit our university. Right, so again, back to the idea, I think it's commonly known that COVID-19 have impacted the world. I commonly know that this is what we have learned for the past few years. And the first case detected in Malaysia was actually on January 25th, 2020. Those is already, now it's already more than 2.5 years way to go. That's first case detected. And by March 2020, the country authorities or the government actually have announced what we call here in Malaysia as MCO, Movement Control Order. Means that lockdown is commonly known in the whole world, and the whole world actually are in lockdown policy. So Malaysia also not spares for this, and the government have decided on March. I think those Malaysian should know that March 18 is a very important date. Because that's the starting off of MCO and all the other variants of MCOs that is available. You know, we have RMCO, CMCO, and all sort of different sets of MCO that we have until 2021, right? We go through numbers of lockdown periods, but the first lockdown was the most strict one because everything was closed. No one on the street. With and that was the best. That was the most restricted, and only going out to buy some food, and that was really checked by the authorities also whether you can go out or not, and so on. So Those were the first thing. And like any other countries in the world, Malaysia stock market was was also impacted by the pandemic. So again, this is the motivation behind the pandemic come into picture, and then after that it affect not just the stock market certainly, but our focus on the paper here research is about stock market, the impact for it first, and then it translated into unemployment later, which is what we want to test in our understanding of what we call as farmers' hypothesis, which I'll explain in a while. And these are some relevant studies on Malaysia, especially related to stock market. Like Lee et al. 2020, we have Chia et al. 2020, and then we have Liu et al. 2022 that talks about the stock market. What I highlighted there, what I bold there actually shows that there's a negative relationship, between the COVID. In this case, most of the time the studies take the numbers or the new case itself or death toll itself towards the stock market. Means that there's a negative relationship as I put here in bold. Negative relationship here. Sorry, let me go back here again. Oh. Right. Here in this sense, we have negative relationship. We have negative adversely impacted and also the latest study in 2022 that published in Singapore Economic Review in 2022 about day of effect on whether there's a day of effect kind of impact towards the stock market, and they Liu et al. Found that there's a significant day of impact, and Monday returns, especially on Monday returns of all the selected index were negative, means that they were negatively impacted by the COVID. All right, that's the storyline, that's the motivation behind also, right? Next one is that what's the issue, what's the motivation behind the COVID-19 impact the stock market? And then these farmers hypothesis stated that there is a long-run relationship between stock market and unemployment. In that sense, these authors, a series of publications from these authors in 2010, 2012, 2013, 2015, hypothesized that financial crash or stock market crash will impact or will have high impact, persistent high unemployment rate. Means that this financial crash can be from the COVID, from the pandemic or any of the downturn in the economy, like what happens in times of financial crisis, for example, in times of pandemic crisis, in that sense. So the COVID bring forward the stock market to have negative impact, and then this stock market would bring some impact towards the unemployment rate in that particular country. That's what the meaning. That's what we try to bring this hypothesis, not the first one, but the second part of it, which is called farmers' hypothesis. That's what we're trying to test, and the issue and the motivation behind. Right. So this is what we plotted from the data that we have, from these particular studies that we have, based on these two relationships. The one in red color actually refers to stock market. The one in blue color refers to unemployment, in that sense, that we plotted based on the daily data that we have, right? That we collected from the sources that we have, that we use in the estimation here. We found that you see that there's a kind of P there refers to stock market, U there refers to the blue color refers to the unemployment. So there's a kind of relationship which explained just now by Dr. Jerome. This can be terms in terms of time series data. This can be terms as non-stationarity. Look at this graph only, but we have to test to prove it statistically. And then the idea of co-integration is that the two variables are having a common trend or moving together into the long run. That's the idea of co-integration, long run co-integration here. So if you look at the graph like this using our own eye, it seems like they have that types of relationship, but we have to prove it. So that's part of farmers' hypothesis in that sense. So and these are the day's data, and the data is actually collected especially during the peak in 2020 time, when the COVID-19 was the beginning and pick up in 2020. So our data is on the 2020 data especially. So the objective of the study is actually to investigate the long run relationship between stock market and unemployment during the COVID-19 pandemic, and the sample is actually from here, January 2020, which started off the COVID in January 25th, and then until October, end of October 2020. So daily data, high frequency daily data, because we can get the kind of daily data, we can convert the data that we have from our one of the cohort actually who are related in peso. So in terms of that, we can get the kind of data that we want to have for this particular research. Right. So the simple model and methods that we adopted here is back on co-integration, back on the time series, standard time series analysis, between these two, unemployment and the and P represented by the stock market, stock index itself, and P is actually the stock market, and Z actually I think I deleted off the Z. This Z variable here actually. This Z variable here actually represent, we put in two additional variable or control variable of new cases and new deaths, but our focus is actually on this one. We put in this to have that kind of impact of the COVID towards also unemployment, towards this particular variable itself. But that's not what we want to have, the main objective that we want to look at. And all the variables are transformed into logarithm, so means that we can interpret as elasticity. So this is the method from unit root. I think we apply about 4 to 5 unit root tests from the ADF, VP, KPSS, and Peron, I think DFGLS. We adopted quite numbers of unit root methodology, and then co-integration also, we adopted quite numbers of co-integration, excluding the Johansson and Jusilis, the famous Johansson and Jusilis. We adopted the angle grandeur, we adopted, this is all the, after the co-integration we estimated, but this also can prove that there is a long run relationship from FM OLS, this is called fully modified OLS, then we have this dynamic OLS, and also canonical co-integrating relationship, which is which is also the regression after we have the co-integration being detected. And also we go ahead with later after that, we want to estimate, or we want to know the causality direction between the variable, because we want to ascertain whether actually the farmer's hypothesis hold or do not hold in that sense. That's our main objective based on the title. That's on the objective that we have. So we use VAR, vector autoregressive, and we also use another method called Toda Yamamoto causality that estimate the long run. This one is the short run because it's in first difference in that sense. Right, move forward to the result. This is the summary of the result. The full result actually with the tables all is available in the paper, which I can share with you. Right, result indicates that all the 4 series, we have unemployment, KLCI, the new case, and the death for COVID. In I1 means that after first difference is I1 in nature. So after first difference, they are integrated of order 1. Right, all variables are stationary after first difference. And then the second one is that we estimated 4 estimators for the co-integration, which shows that stock market shows a linear and positive effect on unemployment. Means that there's a linear, in this sense we only estimate linear co-integration exists between stock market, unemployment, and the 2 additional variables that we have that we put into the modeling process. Right, in the short run we detect there's a unidirectional running from unemployment to the stock market, unemployment to the stock market for leg 2 and leg 3. We tested leg 1 up to leg 5. right? Just for the purpose of having, the short period of time, the longer period of time. For the higher legs of 4 and 5, our result indicates that actually stocks impact the unemployment, which indicating the farmer's hypothesis in a much more longer period of time, a higher leg is served. Same thing in the long run causality, we also detect quite a consistent result. So we summarize in such a way, easy way, like what been explained by Dr. Jerome just now, using a figure, using diagram to represent the causality direction. So this is our causality direction. SR means short run, LR means long run causality. Short run and long run causality, leg 2, leg 3, unemployment to the bursa, which is the KLCI. And then in the much more longer period, or leg 4 to leg 5, in long run is leg 5, we have a causality direction running from Bursa Malaysia to unemployment. And in the long run causality, based on Toda Yamamoto approach, in leg 4, there's a bidirectional, means that both causing each other. So here, actually based on this result, in the much more shorter leg, this is what happened. In the much more longer leg, it's actually support the farmer's hypothesis, what we want to test, in that sense, whether that exists in terms of Malaysia data by itself. So conclusion, very straightforward. We test the farmer's hypothesis. We found that long run relationship exists. So this is the first. We already support the farmer's hypothesis. The second one is that the causality direction suggests that in the longer period of lag, farmer's hypothesis hold. Farmer's hypothesis hold in that sense means that stock market does impact unemployment. Stock market does impact unemployment. So we have two implications from the studies, which can be very important for the policy making and what happens right now in the country. Right. First is that we found that there's a significant long run relationship between unemployment and stock market, which indicates that the information of the stock market can be used to forecast the future of unemployment rates. That's the first one, the implication. The second one is that farmer's hypothesis only exists in a much more longer legs, longer period of time in that sense. And what it means, how we interpret it is that it implies that the restoration of individual or investor confidence on the stock market can be achieved through direct government intervention in the stock market. So what Farmers 2015 says that interpret in that sense how we can adopt that in our in Malaysian context is that according to the animal spirit explanation of the recession, the intervention in the stock market were significant factors in engineering the stock market recovery. That's what happened in the country. So the stock market not crash yet, but stock market being impacted. And what the country, the government of the country, Malaysia government doing, not just for the stock market, for the whole economy, is just to have a proper plan for the recovery of the economy. As what we've seen right now, towards the recovery, despite that there's still some hassle. Our pressing issues right now certainly is about rising inflation, rising price in the country, which affected the whole world too. But then again, what this paper suggested is that with the government intervention, into the stock market, we can detect the farmer's hypothesis in a much more longer period of time. Means that it takes time for the government to intervene in the stock market, and then we can prove that will impact the unemployment itself, which support the farmer's hypothesis, right? Increase in confidence, increase in stock market value, subsequently enhance economic growth. It will lower the unemployment, hopefully, in the much more longer period of time towards that. But with the proper intervention, certainly, as what all the government in the world are doing, when the COVID hit, pandemic hit, not just Malaysia, Indonesia too, and the rest of the world, government putting up stimulus packages around the world. Not only that, but also other types of policies that will enhance the economy would also enhance in this sense, of which our focus is on the stock market itself. So, and with a much more, of the intervention and much more longer period of time towards that, beyond like 5 and so on, it was hopefully to lower down the unemployment rates, right? That's what we found, and this is the paper that is forthcoming in the journal called International Journal of Economic Policy and Emerging Economy. It should be out by next year, I guess, 2023, because it's just been accepted this year, and we prepared the work actually in end of early 2021. We sent to the journal early 2021, it'll be reviewed and so on, and after that accepted this year, it's supposed to be come out for next year, 2023. And this is the paper. The full text, if you're interested, is available. You can I can send to anyone that is interested. And with that, thank you very much for having me, for having our UNIMAS here. We hope our Indonesian friends would, if they want to ask perhaps, question, perhaps we can have that session after this, finish up our next speaker. Right, so with that, thank you very much, and I'll pass back the floor, or we move to the next, presenter, etc. Let me stop sharing. Thank you.
Yeah, thank you very much, Professor Dr. Evan Lau, for the presentation. Very interesting presentation. So maybe can we move to Dr. Agus?
Okay.
The floor is yours.
Thank you, Dr. Jerome, for time given to me to present my paper. Okay, I share my paper. A few minutes. Yeah. Okay, thank you, Dr. Jerome, for time given to me to present my paper. Yeah. My paper entitled Effectiveness of Fiscal Policy on Economic Growth in Indonesia. In economic growth is one indicator in development. Yeah. Without economic development, poverty and inequality are difficult to overcome. Yeah. This study aim to look at the effect of regional fiscal policy and macroeconomic variable on regional economic growth. Yeah. The study used to third of province in Indonesia from 1910 until 2020, but Indonesia have 34 province from Aceh until Papua, but data complete in Minister Financial only 23rd. Yeah. The study use a dynamic panel regression model, yeah, collaboration panel, and VHM. Okay, next. Yeah, this methodology. My model GDRP is equal function population, poverty, education. This education is education budget or government expenditure for education. Health, government expenditure for health. Marine, government expenditure for marine and fisheries. This is a government expenditure for agriculture. ya. And DAU adalah is General Allocation Fund, FDA Foreign Direct Investment. And I plus opinion from BPK. BPK is opinion on laporan regional financial accountability. This is the GDRP function, and based on this equation can be derived. This is all variable. Give logarithm. This is why I give a log in this equation, because I look for elasticity coefficient, and this is this model. This is model. In this model, we have 6 steps in the VHM panel procedure are as follows. Number 1, all variable will be test, unit root test. After we test unit root, we can test co-integration, and test which Granger causality, and we make panel vector error correction model. After we make equation in panel vector error correction model, we derive impulse response function, and the last result is variation decomposition test. Okay, this is on the first test, panel unit root test. Many people can see in the table. Unit root test can be tested by Levin, Lin, and Chu method, M pesaran enzim, IPIEF, and PP Fisher chi-square method. Nah, we can see in the table which Levin, Lee, and Chu method, the probability almost significant. Log GDRP, population, poverty, head, aggregate, DAU, and FDA. But only not significant is education. This is not significant. But marine, this is significant at alpha 10%. If the test of unit root test is used I'm pesaran enzim, there are only one not pass, but almost this variable is significant, and 5% and 10%. Okay, if you see in the table, only PP Fisher chi-square, all variable is significant. Is significant. You can see in the probability. The value is 0.00, and we conclude that this variable, all variable is conclusion stationary. After we test a unit root test, next we test a panel co-integration test. You can see there are 7 co-integration equation at the 0.05 level. 0.05 level. You can see in the start. In the start. Please see in the trace statistic and the critical value 0.05. All the co-integration test is significant. From the result of co-integration testing, there is an indication that 7 of output result of the trace statistic value are greater than critical value. This means that is in the long run there is co-integration in the equation model. Okay. Next, after we test which panel integration, yeah, we test a causality test. Yeah. You can see all variable. Yeah. Test which pairwise Granger causality test. Yeah. You can see in the function of a population which GDRP. Yeah. So in the probability 0.A, yeah, 0.5, that mean less than 0.00006. Now, so in this granular causality indicate that GDRP, yeah, have effect to population. Yeah. So in the second test, population to GDRP, you can see in the probability. In the probability, the value of 0.0051. It means that probability less than 0.05. Yeah. It means population have effect to GDRP. Yeah. So population and GDRP is inter correlation. Yeah. Now, yeah, you can see all the granular causality. Yeah, almost. Yeah, many tests is significant. Yeah, a number poverty and GDRP only. Yeah, GDRP can affect to poverty, but poverty not affect to GDRP. Only correlate one way effect from GDRP to poverty. Yeah. Yeah, you can see in the GDRP and health. Yeah, this is intercorrelation. Yeah, from health to GDRP and GDRP to, I'm sorry, this is GDRP to height and height to GDRP. Yeah. That means many variable can affect, yeah, can affect can affect to GDRP. Yeah. Okay, after we do causality test, yeah. Yeah. Now, I make the result regression which dynamics panel. Yeah. This is we use leg 2. Yeah. You can see in the long term, the statistic. Yeah. Almost. Yeah. The independent variable. Yeah. Independent variable can affect. Yeah. To GDRP, yeah, in the long term, yeah, in the long term, population in leg 1, yeah, poverty in leg 1, yeah, but education height, education government, yeah, not significant, yeah, because yeah. The statistic is very this is a low, less than 1.6. Yeah. Okay. Health is can affect to GDRP. Yeah. If you see in the long term only education budgeting and agriculture budgeting and marine budgeting cannot effect, yeah, to GDRP in the long run. But in the short run, GDRP only, you can see in the poverty leg 2, can affect GDRP. This is the statistic is minus 2.14. Yeah, this is significant at 1%, 1%. Yeah, but height, this is not this is significant only. Alpha is 10%. Yeah, and the foreign direct investment significant in the long term and significant in the short term. But you can see in the symbol in the long term, this is have a positive symbol. So increase 1% foreign direct investment can drive GDP. Yeah, but in the short term, increase foreign direct investment, yeah, this is can drive, but this is a minus effect. Yeah, so 1% FDA can decreasing, yeah, can decreasing 1.6% to GDP. Yeah, yeah. This is in the short term. FDA big problem in Indonesia. Yeah. Now, foreign direct smart investment in the long run has a positive effect, meaning that if foreign investment increase in the long run, it will encourage regional economic growth. Now, Indonesia have 270 million people. Yeah, so many people need employer. Now, in the long term, in the short term, we need foreign direct investment. But in the parameter in the short term, this is a negative minus 1.9%. For example, if you see Papua, yeah, Papua have a Freeport, yeah, but Freeport, this is a foreign direct investment, yeah, from USA. Many if increasing in the product of Freeport, yeah, only less given to value added, yeah, value added from Indonesia. Yeah, now Jokowi have a program, yeah, to increase, yeah, value added from industry, yeah, Yeah. So you can see Jokowi, Indonesia have yeah, have Indonesia ini ya have mining, ya, in many province, but in the long term Jokowi to protect infant industry in in Indonesia, ya. Okay, ya, you can see this is a result dynamic panel, ya. This is a problem in the short term for FDA, ya. FDA have a negative effect, ya, to GDP, ya. This is a big problem from Indonesia, ya. Okay, from this regression, ya, we conclude, ya, we conclude, regional economic growth in Indonesia is influenced by regional fiscal policy in several macroeconomic variables. Budgetary policy forehead affect long-term economic growth through increasing healthy living and increasing community productivity. Indonesia forehead is very I think not very cheap because if many people sick in Indonesia need much money to go well, the role of the general allocation. Do you know general allocation fund? If central government give a province or city to allocation from tax and usually allocation fund from general from DAO are used to mass project, and government hope to increase DAO can increase GDRP, but many people in government make a mistake in program, many program can affect or negative effect in the long run on economic growth. This show that the general allocation fund used to overcome budget deficit. Aim at correcting economic growth is not well targeted. Based on this result, local government should begin to change budget management that not only see success from the output products, but also from the outcome arising from the program. Second conclusion, this is a direct foreign investment in the long run has a positive influence, but the contribution it creates is very low in driving regional economic growth. Foreign investment entering region tends to be capital intensive and requires educated human resources. So that foreign investment is not significant in reducing unemployment. Central and local government must be selective in choosing foreign investor, and investment that tend to be labor intensive is preferred. So that the entry of foreign investor can encourage economic growth through reducing unemployment, through creating new jobs. This is the last conclusion. The opinion of the financial audit body has a very big influence in driving economic growth. The impact of obtaining a fair opinion on the financial statement on the local government makes strong community support and participation in supporting the success of blue government work program. In the long term, the regional government financial report, which are considered reasonable, will encourage regional economic growth. This is realized by using money for targeted development program. I think this is my present my paper. I hope many people can ask this people. Okay, Dr. Jerome, thank you for time to present. Thank you.
Yeah, thank you very much. The presentation from Dr. Agus. Okay. So we have very interesting presentation in terms of the applications of the econometric concept right into the papers presentation by Associate Professor Dr. Evan Lau and also by Dr. August. So probably if you still have some time, probably we open to the floor if there's any questions. I mean from the participants or especially for the students. Yeah, any questions or anything that you would like us to clarify? So you may ask. Yes. Oh, Dr. Dimas. Ini Dr. Dimas.
Thank you very much, Dr. Jerome, Dr. Prof. Evan, and Dr. Agus for having me for just ask some questions. Not question, but want to get some clarification regarding what you have already presented just now. I'm enjoying this presentation that you have conducted just now. By the way, looking at some issues in the econometric point of view. If I may ask to Prof. Evan and Dr. Jerome, and perhaps a little bit to my colleague, Dr. Agus. The first to Dr. Jerome is concerning to the regressions. Somehow we face so many problem. Some of the problem is the called autocorrelation problems. Yeah. So the residual somehow correlated each other so that the result is not that good. And there are some method that could be used in order to settle that autocorrelation problems. Some of them is to how to make the Dubin-Watson is at the expected interval. Yeah. If you remember, perhaps the Dubin-Watsons between 2 until 2 point plus, like that. So not below the 2. So my question is to you, Dr. Jerome, just to get some information is how if we cannot solve the autocorrelation problems? Somehow we have conducted so many settlement. We have already conducted some statements, yeah, in terms of data, but in the end of the day, we still have this autocorrelation problems, and also it is exists in the context of students. Somehow, if they are conducting some mini tests, they still have this kind of problem. Could you give some maybe advice to the student here, including me, how to settle these autocorrelations until this is not exist at all, or maybe secured in the end of the day? And the second one to Dr. Prof. Evan, I'm quite interested to see your result that you find that the time lag that you find from unemployment to stock markets, yeah, and from stock market and unemployment, the time lag is quite longer, yeah. In the case of unemployment to stock market, you found 2 until 3 lakhs, yeah, and in terms of the stock market to the unemployment until 5 lakhs, yeah. So could you please elaborate more, Dr. Prof, why the correlation between the stock market to the take longer lag, yeah, compared to the unemployment to the stock market? So actually, what happens in the case of Malaysian stock market so that it impact to the unemployment still longer, yeah, or maybe quite not fast for in terms of this finding? And the third one to Dr. Agus, perhaps just humble question, Pak Agus, concerning to the FAR or VECM. So in case that there is the data is not stationary after the first difference, Pak Agus. So what can we do, Pak Agus, so that the the econometric point of view can be processed for the next analysis. So having given the first difference not settled in terms of the VACM, so what the next one, Pak Agus, what the advice to do? That's all perhaps, Dr. Jerome, Prof. Evan, and Pak Agus. Thank you so much for the answer.
Yeah, thank you very much. The question from Dr. Dimas. So very interesting question for the three speakers. All right, maybe I will just begin to address the first question by Dr. Dimas, which is about the auto serial correlations problems. So as we know that we're talking about the serial correlations is one of the we refer back to the classical assumptions is regarding the error terms, where there are two correlations between the two different error terms. It's based on the classical assumptions. And then, like the Dimas did mention, normally can use based on the Durbin-Watson values, because we know that the values from 0 to 4, and then 2, the value of 2 is indicating that there's no autocorrelation problem. And we know that if we're doing the time series analysis, then most of the time that we may encounter this serial correlations problem is quite common. For example, heteroscedasticity normally is from the cross-sectional perspective. It's quite common to observe that. But in talking about the serial correlations, it's most probably is due to the longer time period. So therefore, there could be these serial correlations problems. But most of the time, how do we engage or to overcome this problem? Probably you can using a different increase using the lag variables in order to overcome these serial correlations. But of course, it means that you create using the different lag here, not just at the static values, but probably you can use t-1, the previous lag, to add on maybe 2 lag or 3 lag to see whether it can overcome these correlations problems. But when talking about using the lag variables, we need to also be cautious which lag variables that we're using. So if you look at the theoretical perspective, it's based on the if you use the lag variables of the dependent variables, right? Which means that the yt-1 as part of the independent variables then probably the Durbin-Watson d-test it cannot be used anymore. Then you need to use another Durbin test to test on the result. So that is from this theoretical perspective. But when it comes to this the practicality, you run the EView, for example, when it comes to this diagnostic testing, there's options that for you to choose the number of lags that you can include for the diagnostic testing. So that could be one way of how we can overcome these serial correlations problems. But on top of that, probably like the basic structures of the data that we have, for example, like you standardize the measurement unit. So that could be one of the ways. And probably also more data is better, like the number of sample size. The greater, larger sample size, then in fact it can not just solving these serial correlations problem, but could be also other diagnostic problems that we can overcome. But if we're just basically talking about the serial correlations, probably I would think that the lack of the variables can be one of the methods that can use to address serial correlations problems. That is my opinion. Okay. For the second question, maybe Dr. Ivan would like to address.
Thank you very much for the exciting. For the question itself. That regarding on the research that we have done. So what we have found actually has been, I think, further explanation is that why perhaps this thing happens in the sense of Malaysia scenario. We have to remember that we are testing based on the data that we have. So what we found, as already mentioned just now, with a shorter period of lag means that about like 2 or 3, that we do not find this hypothesis that eventually that proposed by farmers that says that the the stock market or the crash in the stock market, especially the crash in the stock market, will impact unemployment. But the question is that how long does it take? How long does it take to have such an impact? Right? How long does it take to have such an impact? So what we found actually, based on the shorter period of lag, even in the short run and the long run causality that we are using, that such an impact doesn't exist. But with a much more longer period of lag, then those evidence have been detected from our statistical regression, statistical analysis itself, which actually brings to a point that perhaps not just in stock market, but also in generally in the economy, the economic growth, the impact of something significant happens will not straight away have the impact of the other variable. You know, like something significant happens, like for example, certainly when the stock market crash happened, yes, it might impact the workers, and so on, which leads to unemployment itself. But the impact are not directly being detected in that sense. So that's why the impact from the perspective of Malaysia, if I could explain in such a way, that the impact is not directly, means that if stock market crash today, for sure tomorrow the workers are still employed, but perhaps towards a period of time they might be unemployed. That's what the meaning of the result here means. It brings the impact will be there, but not immediately happens, right? Not immediately happens. That same thing goes to the policy making. Same thing goes to when like in this example, the financial market crash or the stock market crash, or we say that our economy are in recession, but the impact are not immediately felt by the people, but it will be felt slowly by the people, slowly and surely in that case. So this our result bring that kind of meaning. So, and go back to what Dr. Jerome just now mentioned about lag. So this is about how we model the process, modeling the econometric process in terms of adding up the lag. So even though at lag 1, lag 2, perhaps, for example, we don't see the impact, it doesn't mean that the impact is not there. The impact might come a little bit slower than that. So that's how I can try to justify our results here in that sense. And I'm sure you can see also what happens around right now, right? I mean, the expectation that people, that a lot of economists, even the politicians, even the government are talking about the rise of living costs right now, even, I mean, after the pandemic. It's there, but it will come slowly, and the rise of price will come slowly, not immediately. Perhaps because of the war and because of the pandemic itself. So it will impact our economy, not just Malaysia. And this is beyond what I'm trying to explain in terms of my paper. I mean, our paper here. The impact will be there, but the lagging impact. So that is where it's very much important also for the government. The timing of the intervention is important. The timing of the intervention for the policy, for the effective policy making, like what also been mentioned by Dr. Agus just now. The impact perhaps on the expenditure, on perhaps on the budget in terms of provinces. That might lead to the impact towards the government, the central government, but then the impact might not immediately felt. It will slowly bring up to the impact. I hope I make some sense there. Dr. Dimas, thank you very much for the question.
Okay, thank you for Dr. Dimas. Dr. Dimas, a question about why if in HCM, FAR or of HCM, test of unitary test not pass, yeah. But if you use data level, tend to Securus regression, yeah. It means R square is bigger. Many people see of result of regression, one C of test of order, yeah, C first order test, only CT test, only F test, and R square. But R square is bigger. This is one criterion. Yeah, many criterion to see the good model. Yeah, yeah. To avoid sequence regression, you can use first different. Yeah, but I'm not recommendation for you about the second different, about delta for delta or different from. Yeah, this is uh, uh, very ini ya confused for me ya, because delta for delta. I recommendasi Dr. D must only use first different, yeah, because if the second different, this is difficult, yeah, to presentation in economic. Yeah, for example is GDRP. First different GDRP is economic growth, but second different different from first different is this is ini ya problem or very difficult. It mean in parameter ya. I only if use a dynamic, please use a first different. I think or this case have not pass in first different, please, yeah, change which logarithm. I think many data if use logarithm pass on first different. Yeah, if the result is second different, please add logarithm. Yeah. Okay, thank you for Mr. Dimas.
Yeah, thank you very much, Ivan Love, and also from Dr. August for answering the clarifications on the question from Dr. Dimas. Right? So, is there any also open to the floor for the others if there's any question?
Good day, doctors.
Yes.
I would like to ask a questions. Regarding to the panel data analysis, whether the normality test is important for the panel data analysis, whether we need to test the correlation, the heteroscedasticity, so on and so forth for the panel data, for the macro panel data.
So for this, the macro panel, so it's the long panel. There's the thing when we're talking about the panel configurations, the diagnostic test will be a bit different because the natures of the structures of this panel, because they stack the two dimensions together. So of course it becomes more complicated, but it can overcome actually can overcome those some of these diagnostic problems, like those hetero or serial correlations issues. They can address that. So probably, I mean, the diagnostic test will be a bit different. So for example, if you're talking about the long panels, macro panels. So the things that when it comes to the estimation part, for example, you're choosing between the mean group estimators and the pool mean group estimators, then you apply the Hausman test to select the models that you think that is appropriate for you to do the estimations. Right? So what I'm trying to say here is probably the diagnostic test will be a bit different, where those normal common like the hetero and hetero correlations, it can be overcome if you're using these panel structures when you do the estimations. So I understand because it's big different from the way you do the time series, where those diagnostic test is a compulsory for you to test on that, because the time series only indicated from one dimension. Okay? But when talking about the panel, that is the advantage of using the panels accommodating the two different dimensions. Then, of course, when it comes to the diagnostic test, the priority wise will be in terms of the other type of the testing, such as the selections of which models is appropriate. So that is my opinion.
Oh, so that's mean that we need to use the random effects, the fixed effect. Then later on we test for the Houseman test, so on and so forth, right? Is it?
Yeah, that is quite a standard procedure in terms of selections of the model.
So whether is it possible that the random effects that I run it through eViews whether is it possible that there's an error coming out when I run the testing from a pool ORS to random effect, whether is it possible to happen or something wrong with my data?
It is quite subjective because I don't see your data, so I'm not sure. But probably you need to relook back at how you structure your database. Okay, so that is very important. If there's some error where the eViews cannot read your database, so probably will provide some very unusual outcome. Okay? So it probably you need to relook back at your database that you have. Okay.
Okay, thank you, doctor.
Yeah, all right. Thank you. Is there any more other questions?
Good afternoon, Dr. Jerome. I do
yes.
have some question. I have one question for Dr. Agus.
Please.
Okay. Okay. I want to ask is about the what we should do if our custom test is not stable.
So you are referring this question to Dr. Agus?
Yeah.
Dr. Agus, would you mind to address?
Okay, I try to answer this question. If this model is not stability, you can manage Alex. In the VHM, and there are two tests. After you test leg length criteria, you can use the stability. The stability because if this is a stability, you can use you can use a tabel to forecasting in the last result in VHM. If this is not stability, you can manage legs. If you choose the leg criteria is a 3, you can use leg 2. I think the result this model is can stability. Okay, thanks. Thank you.
Thank you, Dr. Agus. So any more other questions? Okay, so I think no more questions. Okay, I think that will be all for today. So maybe before we end, maybe you can take photo for a while. Okay. So I just like to, on behalf of the Faculty of Economic Business and UNIMAS, thank you to Dr. Agus and Dr. Dimas.
Okay.
And also I think Miss Gina for the coordinating committee for the arrangement for these lectures series. So indeed, it's very beneficial for both institutions. So thank you to Professor Dr. Evan Lau also for joining together with me as a speaker with Dr. Agus, and then also thank you to all the students from FEB, UNIMAS, and also the students from UMY. Okay? So it's really glad to see of us here. Right? So maybe before we end, probably can we switch on? Can you please switch on our camera? We just take a quick photo here. Would you like to turn on your camera, take a photo? Okay. So just keep smiling, because there are nine pages here. Right. So I can start to take the photo now. So keep smiling. Okay.
Don't stop smiling.
Keep smiling. 3, page 4, page 5, page 6, page 7, page 8, page 9. Okay. All right. So okay, done with the photo taking. So it's very interesting to have this virtual photo taking. All right. So yeah, thank you very much.
Dr.
Once
Jerome.
again. Thank you.
Thank
Yeah,
you, Dr.
thank you.
Jerome and Professor
Thank you.
Farhan. Yeah.
Okay, Doctor.
To join you. Okay.
So thank you. I think that will be all for today. So please do take care and stay safe. So looking forward for more activities with you and Y.
Okay.
Right. Thank you.
Very much.
And have a nice day.
We hope to visit the university very soon, perhaps at